Welcome to today's Software AG webcast titled, How Royal Bank of Canada Exposed Mainframe Data to Create an Active Data Warehouse. Today's webcast will be presented by Harpal Gill, Vice President, Global Alliances at CONNX by Software AG, and Nikolai Chmatov, Associate Director of Business Management at RBC Investor and Treasury Services. As we move through today's presentation, I invite you to submit any questions that you may have via the Q&A box, which is located in the top right corner of your webcast dashboard. We will address your questions at the end of today's program. In the event that we're not able to answer your question, your submission will be noted, and today's presenters will be back in touch with you as soon as possible. Additionally, today's presentation is being recorded. This program recording will be made available to you in an email that will be sent to you later this evening. Additionally, this webcast recording will be posted to the Software AG YouTube channel later today. Before I turn today's presentation over to Harpal, I would like to briefly introduce you to Software AG. Software AG helps companies with their digital transformation. With Software AG's digital business platform, companies can better interact with their customers and bring them on new digital journeys, promote unique value propositions, and create new business opportunities. In the Internet of Things market, Software AG enables enterprises to integrate, connect, and manage IoT components, as well as analyze data and predict future events based on artificial intelligence. It is now my pleasure to welcome Harpal Gill.
Thanks, Will. As Will mentioned, my name is Harpal Gill, and I'm the VP in the CONNX group. I'm going to spend a few moments giving you a quick overview on what the CONNX group is all about. I'll talk a little bit about the CONNX products, and then I'll turn it over to Nikolai, who will actually take you on a tour of how RBC was able to expose mainframe data. CONNX has been around for over 20 years. We do two things, data access and data movement. Data access to over 150 different data sources on a variety of different platforms, and data movement from any of those 150 different data sources to any of those 150 different data sources. We have over 3,200 customers worldwide. We were actually a partner of Software AG back in 2004 and were acquired by Software AG in 2016. We have a number of customers spanning a number of different verticals. As you can see, RBC is prominent there in the top left-hand corner, and we will be hearing from them later today. We also have a number of partnerships. Some partnerships are OEMs, where organizations like Fiserv, Kiwil, ADP have OEM'd CONNX to provide data access or a variety of different data solutions to their customers, or partnerships where customers or partners like Oracle, Microsoft enhance their suite by adding CONNX drivers or data access components or data movement components. What does CONNX do? Well, CONNX has a number of different components. I mentioned earlier we do data access and data movement. At the center of this chart, you can see a data wheel, or the CONNX data wheel, which depicts some of the 150 plus data sources we support for data access. Everything else is an add-on to that technology. So the top two boxes are our data movement solutions. Data sync is a near real-time data movement, change data capture solution that allow you to move data from, again, any of the supported 150 different data sources to any of the 150 different data sources. Instant DB sync is a real-time data replication, change data capture tool with a smaller subset of sources, and again, to any of the 150 different data sources. We also have some visualization tools, and those are the bottom two boxes. We have KPI Sync, which is a mobile solution that lets you visualize key performance indicators in a mobile device, being Android, Apple, Microsoft phone, or equivalent tablet. On the right-hand side, we have a couple of tools. Infonaut, it is a report and query tool that ships within the CONNX product. And then we have an add-on to Excel where we can actually visualize any of the data sources that we support with 2 clicks. The bulk of the presentation will be focused on the CONNX data access. In Nikolai's presentation, he will talk about data access to Adabas and some other data sources. And so this is a better pictorial of some of the data sources we support. Again, over 150. The main thing I wanted to share here is we can actually, regardless of platform, mainframe, desktop, mid-tier, cloud, we have support for a multitude of platforms. One of the additional features of the CONNX database adapter is the ability to not only provide data access, SQL access, ODBC, JDBC, .NET, or OLADB access to any of those supported data sources, we can also virtualize multiple data sources. So if you can imagine you've got data on a mainframe, data in the cloud, and maybe something on a different environment, and you want to virtualize those into a single view, CONNX will allow you to do that. At this point, that is the overview of CONNX that I wanted to share, and now I will turn it over to you, Nikolai.
Okay, thank you. And 1 second. Hello, everyone. My name is Nikolai Chmatov, and I'm working for RBC Investor and Treasury Services on the position of the Associate Director, Business Management. Currently, I would like to capture your attention and transfer it from the kind of a theoretical way of using the products to the practical side and share our experience, how we are using products of Software AG, the CONNX, and what is the way of our implementation. So let me start with the simple thing, such as the introduction of the data and big data itself. It is not a secret, it's pretty open data, that we are expecting soon that our data in 2020, which is practically next year, becomes a 35.2 gigabyte. If anybody can imagine what does it mean gigabyte is, and in terms of like a tapes or in terms of like a hard storage, how big it is. And definitely to have a good navigation within that data, we need actually a good tool. So what we have at the beginning, our data source was presented as the different databases because historically each in-bank application was created with the different tool. Don't ask me why. This is just a historical things it's given, and sometimes it's because of the purchasing the different side of the businesses, sometimes because of the different flows within a IT structure preferred using one tool versus the another one. And finally, we have a kind of a zoo presented with our data sources. It could be different databases such as DB2, Adabas. Of course, everyone started with the VSAM, ESAM, Ingress, and any other databases as the data storage. So basically, the idea to amalgamate that information in one place actually presented as the data warehouse solution. Nothing wrong with the data warehousing itself, but if we look patiently into the original or classical understanding of the data warehousing, the data are going through the extract transformation load, or what we call ETL load process. Then that was not actually enough because our data is subject to change, and in some cases, in some applications, it is changing like every hour, in some cases even like every second. And because of that, the data warehouse come out with the additional adjustment, which called incremental data update. All that information are going to the data warehouse and now through the analyzing tools presented as the dashboard. But now, try to think that you are driving your car and your dashboard on a car showing you a previous day or 1 hour before information. The level of fuel, the speed, temperature, navigation also will telling you where you've been hour or 2 hours ago, or even like a past day. So it's not enough, absolutely. And because of that, the data warehouse, in a classical meaning, was not satisfied our industry. I'm talking about our investor and treasury services. And basically, we start thinking, what else available for us? At that moment, we've got most of the products developed using Adabas and Natural, and the main database was Adabas, and application was written in Natural. So we start thinking about, if we look at the left top corner, like traditional warehouse. This is how we started with. The daily, overnight data transferring, predefined queries and reports, which is not bad for most of the clients who actually follow with the end-of-day information. Then, at the same time, the business requirements is, I would like to see a real-time data. I would like to take a decision based on what exactly going on with my business, with my investments. I would like to run ad hoc queries and reports to control and monitor my business. And basically, from that business requirements, we come up with the idea of the active data warehousing. Well, number one, it is a real-time or good-time update of the data. Predefined triggers and queries to detect significant events, and performance for the query and calculations and grouping. So basically, we have a set of the queries embedded, always the parameters, so we can react on the situation based on those parameters and inquire real-time data. And if we look at the right bottom corner of that slide, so basically, if we look at the business event, which is marked as green on the top, then we have time to action taken. And the idea of the active data warehouse is to make the distance between a business event and the action taking as small as possible. That was our major purpose of going with the active data warehouse concept. So there's 3 data warehouse models. Enterprise warehouse, collect all information about the subject of spanning the entire organization. The data mart is the subject of the corporate-wide data. This is the value of the specific groups of users or businesses. It's scope of the specific selected groups, such as the marketing data. And the virtual warehouse or active data warehouse, the set of views over the operational database. Only some of the possible summary views may be materialized. What does it mean? In the active data warehouse, compared with the traditional data warehouse model, we are not in a position to store any data for the very simple reason. Let's say if only one file in our database may present a couple of millions of records, we cannot actually store it every second or every minute or even every hour because it would be too much. So the idea is only virtually have access to the data. Practically, in a new language, I would say we create a view, or better to say it is a link to the data, what we actually store in another base. And so when we observe all those 3 approaches, we select the last one, the virtual warehouse or active data warehouse, as our mainstream. So let's have a look at this slide. So what we can see, that was driven by the business wishes, like a Christmas list. anything was going on with our business side, we create a new loan, assets availability, anything changed on the market side, such as the price or any other parameters, collaterals arrived or was withdrawn. Everything is going to be presented as the set of the dashboards, which gives us ability to manage our business in a proper way. And our target is to present that dashboard in as good time as it is possible or be very close to the real time. So here's the generic concept of our active data warehouses. If we look at the bottom side, we have Adabas SQL Gateway, which is the product will give us ability to connect to the Adabas database, as well as we have some additional databases and applications, which is the DB2 based on IS400, Sybase on a Unix platform, Oracle on a Unix platform. As well, we have a VSAM files, which is also part of our business. The next layer, where we have a Adabas SQL Gateway client, which presented at the SQL Server side as the set of views, and then through the ODBC connectivity, through GDBC connectivity, or any other way what's supported by the SQL Gateway, we have a product which we developed in-house, which we call a control view, which has a GUI interface, which gives the ability for the users to deal with the data. We have a control view visualizer, which gives the ability to build and use the dashboards, as well as we have a link with the Microsoft Office, which includes the web browser, Excel, Word, or Microsoft Access. Currently, we have implemented approximately 70 reporting groups. Currently, we have 120 users divided by the 22 user groups, and it is not limited, but in fact, we have connections to the Adabas database, SQL Server, Oracle, DB2, VSAM, Sybase, MySQL, Bloomberg, and Broadridge. So how our concept works? As the source, what I already mentioned, we have Adabas, DB2, Oracle, Sybase. Let's concentrate our attention on the Adabas side. We have a next layer presented at the SQL Server as the data adapters. And you can see market providers, the CONNX already did. This is what we currently use to connect with Adabas database. Then if we look next, the bottom of this slide, we can see the Adabas, the catalog, and CONNX DB, CONNX schema, and different variety of the databases which are connected through that particular connector. The next layer on the SQL Server will have a set of views and set of the stored procedures. Later on, I will explain the difference in approach of using the views and stored procedures. So as you can see, there is no actually tables where we pull the data from the data source. We have a view, and view is basically, it's like a hyperlink to the data where they're sitting, which contains the list of the fields, what we need for a particular reason, and a table where they're located, and they may contain or may not some additional filtering. So basically based on, it is a very, sorry for going back and forth, but let me explain the situation. A long time ago, it was very simple approach to have multiple record types within a one database table. And it is very nicely fit into the approach of using the views. So basically, we can say we have a 20 or any number of views to the same table, which particularly pick up different type of records into the view. The storage procedure we are using for dynamically generated queries, because if we are dealing with the database table where we have millions and millions of records, and we have just only a view with a certain filtering on it, it means that the good portion of that data will be traveling from the source side to the client side, basically over the network, and make traffic very busy. So from that perspective, we are using concept which called remote procedure call, if you will, or remote queries. In SQL Server, syntaxis is called open query. So basically, by doing that, we minimize the number of data participating in the traffic through the network, and we try to do all grouping and calculations on a mainframe side, or at least on the source side. Then, information from that level, data feed level, are going to the Mashzone. On the Mashzone, we create a set of the dashboards, define the particular variables what we can use to modify the query dynamically, and then create the dashboards what is seeable by the end user. As well, the user interface of the product which we create based on the Software AG Adabas SQL Gateway let us present data in several ways. It could be connected as the grid, it can be connected as the report, or even embedded Excel file, as you can see on a cycle number 4. Let's have a look next. On top of it, within a product which we call Control View, we have an advanced query builder, which gives us an ability to build dynamically, build a query, ad hoc query, and store those queries against the Adabas database and use it for the future by the user through that interface, or create it as the additional view and actually address that view at any time and get data in a real time or in a good time, depends on the size of the data. The result can be presented as the grid internally, or can be transformed into the dashboards or export to Excel, or send it by the email as the attachment, or as the link if it is generated Iris dashboard. This is what we can see on the right top corner. It's an email generated and contains the link to the dashboard, which is presented inside the picture on the top left corner. At the bottom of the screen, we can see the dashboard, which is generated through the interface with the Excel. So basically, data filtering and transformation for the active data warehouse, mainly we do through the Iris. And as you can see, most of the things done graphically, and there is no kind of difficulty. It is not a rocket science to build up a relationship between different tables or different fields as soon as the person who is doing it very familiar with the understanding of the data model. As the result, we can see the data visualization can be done through the internal or external interface. As I already mentioned, it could be subframes embedded web pages. It could be dashboards or like a crystal reports or Excel files inside or outside of the application. As well, we actually move forward with Iris, Mashzone, and was able to create dynamically created queries on the Mashzone side, and then address it through the set of the storage procedures and views through the SQL Server, and address it to the Adabas database through the Adabas SQL Gateway tool. And basically, as you can see on the bottom right corner, there's two slides which present both of them created through the Mashzone. When the source, by the way, was Adabas database. So the integration with the Software AG Mashzone products gives us the ability to build up reports which really looks way better and more understandable. Let's look on the left side of the current slide. What we can see, this is our traditional reporting stuff, mainframe reporting. Through the certain iterations, it was transformed to the next stage, and it's become like a crystal report or anything else. But again, we are talking about a set of the big data which needs to be listed from top to bottom to find out proper numbers or proper information. So then, when we switch to the Mashzone, using the same source, we was able to present data in a way which is, first of all, it is active, and you can see right away the cumulative data, the grouping, summary. Basically, this is what we need for the business management side. As I already mentioned, with the Mashzone, we was able to build advanced interface, dynamically change the storage procedures and parameters what we are passing to. And in fact, this is the practically step-by-step way how it was done. So that is the result. And basically, all of those dashboards are interactive. By selecting something, we can see the changes right away on the screen because the parameters are passing by to the SQL Server, which actually perform the storage procedure, which change the query and send that request to the Adabas over the Adabas SQL Gateway. On the server side, on the mainframe side, we have a grouping and calculations, and back we have just only numbers which we need to display on the screen. By changing the cursor position, we also have changes on what we can see on the screen. So as I already mentioned, this is what we call interactive dashboards based on the active data warehousing, because every time when we do some changes on the cursor position or selecting different type of parameters, we have inquiry our source database and getting back a result. By selecting, this is the example number 4, interactive dashboard. So by selecting different type of, in our business called lenders, and we can see and compare, and different dates, we can see and compare the behavior of each of them, what they are doing, how they good at a certain moment of time. It's also give us the ability to analyze the data based on all historical information stored in our application on the mainframe. Sometimes even that type of dashboards give us and to our management way more information than just a regular Excel files or reports, because it's very seeable what is the proportion between different type of say, securities involved in our business. And we can see the number of trades, we can see the daily revenue compared with the volume of the trades, a different type of the trades. And it's really very, very helpful for the business management to have some decision to be made. As well, as I mentioned, everything is dynamic. So basically, by changing the different type of the date, we can see a different result. And I think I'm done, and please welcome with your questions.
Okay, great. Nikolai, thank you. Let's get to it. We do have several. Forgive me because I was typing offline to one of our questioners. So the first one, the questioner submitted it as, how is the overhead of running CONNX on Adabas production? But I'm thinking, do they mean, what is the overhead of running CONNX on Adabas production? Harpal?
Sure, I'll take that. So the overhead for CONNX is actually pretty light. It basically will give you, if it's a mainframe system, we'll put a little listener on the mainframe, and we can actually, we have some statistics that I can gather and share with you, but it's quite light.
Okay. Next one. What are the benefits of using SQL Server versus using CONNX ACE views? Are there any plans to enhance CONNX to provide some of the features SQL Server might be providing?
I'm not sure I understand the question 100%, but let me take a stab at it.
Okay, I can take that question, actually, if you don't mind.
Sure. Sure.
So the reason to use the SQL Server is quite simple. Number one is we do have multiple sources, not only Adabas database, and we are not only using the Adabas SQL Gateway or VSAM SQL Gateway. We as well have a Oracle, we have a Sybase, and sometimes you need more power to amalgamate information from the different sources. And the SQL language itself, TSQL, for example, gives you ability, number one, to amalgamate data, run additional procedures, summarize the data, and present them as in one single view, even it is pulling from the different sources. So basically, this is the step to what we call federated reporting system. If we look at any other possible way of doing the same things, so there is two choices: create something similar by ourselves, or if we look at any other, say, database which can support the concept of the linked servers. It could be Oracle, or it could be Sybase, but in fact, SQL Server provides that functionality very straightforward and very easy to maintain. On top of it, everything what we need to include is segregation of the data access, which is also part of the functionality of the SQL Server. So that is the little of number of reasons why we choose the SQL Server as the middleman between our sources, including Adabas and VSAM, and our front end.
Okay, Harpal, do you have any follow-up to that, or shall I move on to the next?
No, I think that's great. Thanks.
Okay. So just to everybody that's with us, we do have a couple more questions that we're going to get to, but if you do have any questions, please, now is the time to submit them into the Q&A box, and we will address them. So moving right along, the next one I have for you both is as follows. Are there any plans to zip enable ACE on the mainframe? It's
in discussions. There's not a firm plan right now, but it is in discussions.
Would be nice, sorry, jump again. Would be nice to know the source of that question, because Adabas itself, it is zip enabled, right?
Correct.
So the query are going to the Adabas, and Adabas perform them depends on the the query itself on the zip processor. So to put another process on the zip, let's say Adabas, listener of Adabas SQL Gateway, in principle it is probably possible, and SoftwareG probably will think about it. But in fact, when Adabas is already sitting in a zip, it gives the ability to increase the performance.
Correct.
Okay. Moving along, which of the CONNX and SoftwareAG products were used to create this solution?
That solution was based on Adabas SQL Gateway, VSAM SQL Gateway, which is additional listener, additional connector of the CONNX solution. As well, we are using Mashzone, which is also SoftwareG product, plus Adabas database itself.
Okay. Next one I have was submitted a little off with some words, so I'm going to speculate. It is as follows. Are the charts, it says, are the charts have only default options, or are they customizable like in Tableau? I don't know if that makes
Absolutely. We do have experience using Tableau as well. I just do not include the Tableau slides in this presentation. But in fact, when we are using Mashzone, we are using dynamically created queries. So it means that, as I already mentioned, all charts are active charts, and they have parameters. And let me quickly bring you to the one of the slides, which gives us ability to see exactly the parameters. Here's the parameters. Top 20. We can select a list from that list a particular borrower or type of security. When we select any borrower from that list, the picture on the bottom side will be changed. Depends on the allocation across the lenders. It will across the collaterals as well as any other things. So changes will bring the result, and at the end, the Mashzone will dynamically change the query, which will be addressed through the SQL, and that is one of the reasons why we are using SQL, because SQL with that TSQL language gives us the ability to quickly react on those changes and change the parameters, build up a query, and address it to the source. And this is another sample of the dynamic changes, right? So we can select any lender, well, that particular example from 1 to 5 lenders to compare on the list, because to compare more than that, visually, you need a bigger screen than just a regular screen. But one more time, we use SQL Gateway as well as with the Tableau in the same way as with the Mashzone. And the reason why we're choosing one tool against the another one, we cannot say which one is better. They are all arranged for the different purposes, and we try to utilize all of them to get a result. That's all. Okay.
Next one I'd like to move on to is as follows. If a data source is going after a DB2 table, what kind of lock does it use? And can the lock be customized?
Well, the concept of our active data warehouse, we are not going to change anything on the source side. Even all products which we are using as the connectors gives us that ability, but we are not changing anything. for the dashboarding. And because of that, we are not locking the data because we are not updating them. In SQL Server, that construction sounds like with no lock.
Okay, next one I have for you. Is the CONNX data access real-time access to all the data sources?
Yes, it is.
Okay, next one I have for you. Does CONNX use query pushdown to the source?
We have a multiple way of implementing and running the query. As simple as to create a view and more complicated as to create a dynamic view over the storage procedure. Storage procedure mainly using the open query concept, which means that we create the query in a syntaxis of the CONNX and then transfer it to the Adabas listener, CONNX Adabas listener, and everything will be performed on the mainframe side. So it means that we are not doing anything heavy, especially we are not using traffic too much. But if we need to group by, say, we have 20 borrowers, but each of them may have millions of transactions. Instead of pulling all those millions of transactions times by 20, instead of pulling them all and do the filtering and grouping and calculations on the client side, we do it on the mainframe side. So basically over the network, we will receive particularly the result. As well as we tried before we actually, another point why we are using storage procedures for that purpose is when we deploy the query, we try to measure query schema, how it's going to be performed on a CONNX side. So it means that the data plan will tell us which, in which case we are going to use the descriptors, in which case it would be a straightforward browse through the table, and we try to manage that query in a way to minimize the efforts of getting the data. So it means that the set of the predefined queries, which will be able to change through the parameters, but also it is controlled by us, gives us the ability not to actually overuse the Adabas and make sure that the rest of the applications which are using the same database are doing well as well. Hope I addressed the question.
Yeah, great. All right, next one I have for you. Did you experience any data latency or application shutdown?
Not really. That concept already implemented. The first implementation was about 10 or 12 years ago. Since then, we just increase the number of tools which we are using to visualize the data and increase number of connectors to increase number of sources. But beside that, not going to fail.
Okay. Okay, thought I was on speaker. The next one I have for you. Are you using compression or encryption on the ACE client? If yes, how much benefit does compression provide?
Well, compression is really a good option, and I would suggest to use it to everyone, because compression gives us the ability to pass by the network more data with the same amount of bytes transferring over the network. In terms of the encryption, we are not using encryption in a way as it's supposed to be, for a very simple reason, because everything what we have is actually internally used, number one. And number two, we do not store the data. There is no, potentially, of course, any risk may exist, but potentially there is no risk because data only exists in time when somebody initiates the query and get the result. As soon as that screen is closed, nothing else. We do not store anything in a database as the regular tables, because it's like a, it's like a hyperlink to the data. When you click on hyperlink, you go into the some web page. Same thing here. You click on a view on the third procedure with the parameters. You inquire the database, bring back the result. As soon as you are happy to watch that result, if the result exists only on your screen, it's not anywhere else. Then when you close the screen, that's all. Data is not exist anywhere except the source. But to get the source, access to the source, we follow with the all security and regulatory rules, such as like a password to be changed on a periodical basis, complexity of the password, and so and so.
Okay, the next one I have for you. Are there use cases around joining SOAP REST Web Services results with joining the DB results?
I cannot say that we do have a lot, but recently we started doing some kind of like a test to join the data which we're getting through the web services from our new developed applications and our legacy applications, such as Adabas-based applications. But for now, it is just only, I would call it proof of concept. But again, I didn't see any big reason why it will not work.
Okay. The last question at this point that I have is as follows. You mentioned CONNX supports over 150 DBs. Where can I find more on CONNX database support?
I'll take that one. So there's a website under the Software AG parent website. There's a CONNX microsite, and on there we actually list all of the different data sources. And you can also reach out on that website, send a request, and we would be happy to get back to you.
Okay, excellent. With that, then, we have no more questions. What I would like to invite everybody to do, if you do have additional questions, we don't have Harpal's email up on the site, but you can email him at harpal, harpal.gill @softwareag.com. So with that, Harpal and Nikolai, thank you so very much to you both for your time and a very informative presentation today. Our program has now ended. Enjoy the rest of your day.
Thank you.
Thank you.